Hey, good afternoon, everyone. It's really wonderful to see you all. Why don't we begin the program? My name is Richard Locke. I am a professor of political science and international public affairs, and I currently serve as a provost here. And it's my great honor to be able to introduce this session, but also our distinguished speaker. I want to first of all thank you all for being here. It's actually wonderful to have an event where, even though I know there's live streaming, but to have so many people here. It's beginning to feel almost normal. And it's a genuine honor to be able to introduce our new colleague, and I'll say in a minute a little bit more about him. Let me just say a couple things about the Data Science Initiative, which is sponsoring this event, and then turn to introducing our speaker. I would say that the Data Science Initiative, the DSI, is actually one of the great success stories of Brown University. We started it in 2016 to try to bring together faculty and students from across 4 different departments, and it's had spectacular growth because of spectacular leadership. Now there are over 80 affiliated faculty from more than 20 different departments and centers and institutes that are involved in the Data Science Initiative. There's been an explosive growth in the educational programs, whether it's the undergraduate certificate, the doctoral certificate, or the master's program, which has grown both in quantity and in quality. There's a very innovative data sciences fellows program where it gets sort of capable undergraduates to help faculty who need help with their courses and introducing data science principles into their courses. And it's created a really interesting intellectual community. This is everything that you want in a university, is to bring people together, to do important work, and to kind of advance knowledge. Before I introduce our speaker, I also just want to call out our wonderful director of the Data Science Initiative, Sohini Ramachandran. She is a force of nature, has always been a force of nature, but the vision that Sohini has for the Data Science Initiative, trying to make sure that what we're building here at Brown is distinctively Brown. It's taking the field of data science and marrying it to a whole array of not just technical issues, but social issues, including some of the issues that we'll be talking about today. So I just want to thank you, Sohini, for everything that you're doing, have done, and will do with the Data Sciences Initiative. And so now let me turn to introduce our wonderful speaker, Suresh Venkatasubramanian. And tonight, it's a real joy. We've met via Zoom multiple times during the recruitment process, so it's great to see you in person, and so exciting that you're joining our community. Suresh is on loan from Brown, so he's already a member of our faculty, but he's on loan this year at the White House, serving as the Assistant Director for the Office of Science and Technology Policy, where he's actually working on issues related to fairness and bias in technology and information services. Suresh's background is in theoretical computer science, and he received his bachelor's degree from the IIT Kanpur and his PhD in computer science from Stanford. Now, he's taken a long and winding path to finally arrive where he should have always been, Brown University. He's had stops at AT&T Labs, the University of Pennsylvania, the Simons Institute for the Theory of Computing at UC Berkeley, Google, and most recently at the University of Utah School of Computing. He's had numerous awards, including the NSF Career Award and a variety of other things that are quite distinguished. What we were so excited about wasn't just this distinguished career and the accolades in his science, but specifically the work that he's been doing for nearly a decade on algorithmic fairness, and more broadly on the impact of automated decision-making systems to society. And at Brown, Suresh will be starting with our colleague Senni Kamara, a new center, Computing for the People. And those of you who might have watched the Faculty by Faculty seminar series. Senny gave a really terrific talk about this last year. And what this new center is going to do is to help us think through what it means for computer science, for universities, for society in general, how we actually how can be more responsive to the needs of people rather than merely giving people more computing power and not really guiding it. And this is, I think, part of what tonight's talk is going to be about, machine readable. And with that, please join me in welcoming our new member of the Brown faculty and our distinguished speaker tonight.
Thank you, Provost Locke, and thank you to our DSI director for having me here and having the opportunity to speak here today. I should say that my route to Brown may have been circuitous, but I did try. I applied to grad school here and didn't get in, so it took me many years to recover from that pain. So, but I'm feeling better now. As Provost Locke mentioned, I've had a busy few months. It's ever since I finally decided to come here. And people have been asking me, so where are you right now? Are you in Utah? Are you in DC? Are you in this thing? And my answer is usually, I am where I am right now, and that's about all I can say. So I'm glad to be here in this building, talking to you all. This talk sort of started off maybe slightly differently to where it ended up. It was originally conceived of as an argument for why data science must belong in a liberal arts education, along the lines of your very own David Mumford's talk about mathematics in the liberal arts. And the argument that I wanted to make was conceived mostly in the language of data science as utility technology, right? That data science allows us to do things in certain ways. In fact, the success of the initiative sort of shows that many people want to use data science in their own work across the campus. And we need to understand how to use data science so we can do more and better, no matter which discipline we come from. That it's like a sort of a basic tool in our toolkit. And this is certainly true. As a trained computer scientist, I definitely think computing is something we should all learn. And data-driven computing has become a dominant form of computing that virtually all of us will experience, no matter which sphere of inquiry we inhabit. In fact, some of my colleagues in the CS department here are trying to rethink how we introduce students to the field itself using data science. Right? But in my last, almost decade working on the societal impact of data-driven technologies, I've come up against this feeling time and again that the failures and successes of technology in the social sphere, and who knows, we've seen so many of them. To make a chart like this, all I have to do is look at last week's headlines, and I can produce a chart every week which looks more like this, right? That even though we see all these failures and successes of technology, it's not just about the way the tech is being used or even conceived. So the arguments about tech being good or tech being bad or tech being a tool that we wield well or badly, they all seem to miss something more fundamental. And namely, what we are seeing, I think, in my view, is the result of trying to impose a particular kind of worldview on the human condition broadly. So I've been calling this worldview somewhat inelegantly the algorithmic lens. And I think of it as sort of a particular set of ways in which algorithms see us. It's how we are read by machines. So I'm not, this is the obligatory Skynet picture. I'm not claiming we're being taken over by Skynet just yet. Machines don't have agency, they don't have a life of their own, they don't need their own driving licenses, at least not yet. I'm also not merely saying that tech has a distorting effect on society. I think a number of scholars for a number of decades have been saying this in many different settings. Rather, what I'm saying is that when we set out on the path of designing technology that affects people, and that's an important caveat, right? Technology that is people-facing, right? Not all tech. That the way we think about data science has forced us to construct a world that's readable to these systems we're building, and in very specific ways. And so while it's common, and I've done this myself, to build critiques of tech or to sink pains to tech, what to me is more interesting and probably more useful as we think more about some of the challenges we face with technology is to understand how this lens works, not that it exists, and break down the ways in which it operates and distorts, and why so many of its creations has been a source of misery for us. So this idea of lenses that sort of operate on our thinking around the human condition is not is a very common, is a very standard way to approach the world. There are many lenses that we use, right? Especially with societal problems and their solutions. There are historical lenses, political lenses, sociological lenses, psychological lenses. Some lenses are more ideological, some lenses are more abstract. Some lenses are more mathematical in nature. And I'm thinking, two that come to mind often in my, a lens that's often associated with the more neoliberal kind of perspective on economics with a strong emphasis on mathematical modeling. And also the evolutionary lens on psych and society that's popular in some circles. Why do I focus on these lenses? Well, I focus on them because they are abstract lenses. Abstract in the sense of attempting to formalize who we are. Right? They formalize a human as some kind of agent, an active agent with specific functions and roles that can be modeled mathematically. The hope is that by formalizing some fragment of activity that humans participate in, we can reason about this behavior and then draw conclusions about how people behave. It's like physics applied to us, right? So, as you may have gathered from some of my references already, which sends, many of my colleagues are shuddering. I'm a bit of a sci-fi geek. And it would be remiss sort of to avoid any mention of Hari Seldon's dream of psychohistory and the ability to predict the future from Asimov's Foundation series and, of course, the new TV show, which has absolutely nothing to do with the TV series, with the books. And stop me before I go on a long rant. Okay, I've stopped. But the idea is that we could model human behavior with sufficient precision, at least in aggregate, to make predictions about the grand arc of history. That was his goal anyway. But it also seems to be our goal, to make predictions at the local level about human behavior. Much of game theory, the idea of equilibria in systems, mechanism design, and even the modeling of how information flows or a pandemic flows in networks rests on simple mathematical models of behavior and effective models of behavior in many cases. Schelling's model of segregation, for example, is a classic case of using a model to show how slight differences in preferences can lead to widespread segregation, sort of tipping point type of behavior. So we have lenses, and lenses operate to understand, in some sense, misunderstand us as people. But what are the elements of a lens? Well, I think of a lens as having a certain number of things. It simplifies, and therefore, by necessity, must distort. It simplifies via assumptions about the world. And the goal of doing this simplification is to create a world that's easier to understand and interpret. And the hope is by reasoning about the simplification, we can draw conclusions about the world that we are simplifying. And I say all this because my goal here is to try and use this way of thinking about a lens to unpack what the algorithmic lens looks like. Now, a lens itself manifests in a variety of models, right? They might have a model for doing this or a model for doing that. Underlying all these models is some kind of broad perspective on how we think about people. And the thing about a lens that is both, interesting and dangerous is that it often becomes so ubiquitous that the underlying simplifications and assumptions disappear. And that all that remains are models that represent some kind of truth that seems self-evident and obvious, rather than it actually was when we were first creating the model. And so in some sense, just merely naming the lens and pointing it out and saying, look at this, is an important step to realize that what seemed invisible is actually having a material consequence on how you think about the world. So what is this algorithmic lens? So, my goal in this talk is to argue that the algorithmic lens is a source of many of the, problems, but also just conditions that we face in an algorithm-driven society. But, I am a person trained in mathematical thinking, and I realize that before stating properties of this object, I should try to convince you that it does exist. It's always a nice thing to have. You don't have to, but it's always nice to have that. And like I said before, I'm going to keep my focus firmly on the lenses that operate when we use data-driven systems to understand human behavior and activities. Which is not to say the algorithm lens doesn't apply to other kinds of systems, maybe fully automated systems. But what makes this lens interesting and problematic is the fact that we're applying it to people. Right? And that's the human sort of part of this is what's interesting to me. And I'll try to use some sort of working examples to illustrate the workings of the lens, and I'll just pick two among there are many of them. So one example that is becoming a topic of great concern right now is the way in which data-driven tools are being used in hiring. These are just some of the many companies that sort of are putting out AI tools to help with the process of hiring, whether it's screening of resumes or running the interview process or selecting candidates or doing performance evaluation and so on. So there's a whole set of questions one can unpack here. And in fact, just looking at this pipeline itself, you can unpack many elements of the algorithmic lens to understand how they operate. Another example that I will refer to from time to time is one that comes from the criminal justice world, this idea of what are called risk assessment tools. These are also in vogue in many parts of the law and order system broadly. They used to assess likelihood of crime in different areas, the risk that someone will fail to appear in court after they're released on bail, what kind of sentence should be given after someone is convicted, and what terms of release should be set when someone is released on parole. And again, this is a topic of great concern and discussion right now with a number of tools that are out there and a number of concerns that have been expressed about this. So what are the individual components of this algorithmic lens, and how do they work together, and what are the consequences of having those components? Well, it goes without saying, I think, that the most key element of the algorithmic lens is that it is precise. That the goal is to say something very precisely. When I say precise, I don't mean correct. I mean precise. That it looks like it is very well defined. So, we should precisely define all parameters that go into a system, all the data processing required to construct inputs to a model, how a model is learned to predict something, and what the model predicts. All of these things have to be stated very, very specifically in order to implement them in an automated fashion. So the first thing you do, right, when you're thinking of designing an automated system is to say, how do I take something fuzzy and vague and make it precise? And that's the first thing you have to do. It's something we do almost unconsciously. I think as a computer scientist, I do this reflexively when I think about a problem. And it takes time to realize, okay, I am now undergoing the step of making this problem precise. So you want to build a system to do resume screening. Right? You have to decide what format to take the resume in, how to extract the text from it if you don't have text, whether you should collect information on the font used in the resume or not, how you decide which words are relevant, which words are not. And this is even before you decide how to label the resume as meritorious or not for future processing, or whether you should be even labeling it as meritorious or not, or giving it some kind of score. These are all decisions you have to make at the very start of building some kind of automated system to think about this problem of resume screening, or of screening a person or judging the value of a person from a resume. It's one thing to be precise, but how precise, and about what? The second element of the algorithmic lens is this very, very profound belief that more data yields more truth. Maybe I'm trying to predict whether a particular resume is worth passing along to a recruiter, and all I have is the text on the resume itself, but maybe that's not enough information to make a good prediction. And maybe I should get more, because more information leads to more reliable truth. So maybe I should ask for social media data. Maybe I should ask the candidate to submit their handles on Twitter, on Facebook, on Instagram, and God help me on TikTok, Or maybe I should collect information about the fonts used, Who in their right mind would use Comic Sans? Let me not. Comic Sans actually is a good font for various reasons. More data yields more potential ways to the truth, and therefore is always better than less data. I am not asserting this as truth. I am asserting this as a belief that is core to the use of the lens. If you're saying no, that's not true, that's okay. But this is a belief. Right? There's even a precise version of this statement in a certain sense. Roughly speaking, and anyone who learns machine learning knows this. If a machine learning function is trying to learn something from sample data, then as long as the sample data is drawn from the same distribution as the actual data, then eventually, with enough samples, the machine learning algorithm will find the right function as long as it knows what kind of function it's looking for. Caveat, caveat, caveat. And of course, an ML researcher in the audience will point out that this doesn't say that more data will help. It just means that more of the same kind of data will help. This is often confused with the idea that more kinds of data will help. But that's another story. So we have this idea of precision, and we have this idea of collecting data, and that's fine. We have very, very precise piles of data. Why? It's because of this next strong belief that we have, right? That the truth is out there, somewhere hidden in those piles of data. If we just dig deep enough and twist it and torture it long enough, we will find it. And again, this is such a core belief that when I've tried to ask this question, like, why do you think it's there? The response is often nothing, because it is such a core element of the lens that it is hard to question whether this is even a valid claim to make or not. Because humans, after all, have many biases. We are easily swayed by data from our own experiences. We tend to selectively forget data that doesn't fit our preconceived notions. An algorithm can find complex truths and patterns hidden in data that we cannot imagine, because we are limited by our inability to understand very complex rules that might play out over multiple different modalities. We want to predict whether someone will be good at their job. It must be the case that with enough data about someone, we should be able to find something in the data that tells us whether they'll be good. We don't know what that looks like. We probably wouldn't understand the complex combination of factors that leads to that prediction, but the algorithm must be able to find it with enough data and with enough time. So this idea of universality, this hidden truth, right, this deeper meaning that we believe must be there, it carries along with it sort of two other notions. The first is the idea of scaling. Anything worth doing with the algorithmic lens should be able to work as the data you're working with gets bigger and bigger and bigger, and is in fact justified by that ability to scale. Scale is a key component. You could imagine scale being a core part of the lens. I don't think of it that way. I think of universality as a key part, and scale as something that comes along with it, right? If you have the universal truth, well, it should apply and keep applying as things get bigger and bigger and bigger. And the second is a more subtle notion. It's sort of what I'm calling homogeneity, right? A hidden truth exists in this world because at some fundamental, we are all the same. We're all particles subject to the same laws of human motion. We are all the same. Now, this is not a plea for unity. This is a point I'm making that in order for this hidden truth to be true, at some level, these systems have to flatten us out to make us all look the same in order for this truth to be realized. And so a lot of the variations that we see among people get collapsed together, depending on what data collect and how we see them. So we have, so far, in this lens, a precise formulation of a problem. We have lots and lots of data, because more data is more truth. And we have this belief in a hidden and yet discoverable truth underneath this. Okay, but how do we find it? That's all well and good, but how do we do the digging? And that's the last part. The last part, which again is something which you don't think of as something that is a belief, just something that just seems natural, is you have to optimize. What does that mean? The algorithmic lens assumes that whatever it is we're looking for, it is the best under some definition of the word best, a precise definition of the word best. If we're trying to find people who will stay in their job after 12 months, then all we need is enough data on what people we have hired have done in the past. Given that we assume there's some hidden rule that translates from this data to the truth about their job performance, we just need to find it by finding some rule that matches all the prior data as well as possible. That sounds like we want to find the best of something, and we can do it. Have data, will optimize. This is the unseen sort of credo of any machine learning person. And you write on a function, you have some data, and you will optimize for some error measure. Pick your favorite error measure. It doesn't matter, even though it might, and you'll get an answer. And this optimization, this idea of what we want to find can be defined as the best of something, is very flexible. Because okay, well, maybe I want a rule that matches all prior data as well as possible, but also a simple rule that we can explain to someone else. We might want to explain to a hiring manager why the algorithm decided to select a candidate. We might want to explain to a court why the algorithm we used was not discriminatory. We might have to explain to a candidate why they weren't selected for a position. Well, then we must define what simple means, because after all, we want to be precise. once we do that, we can throw that into the optimization as well, because we want to optimize some combination of the best and the simplest. Well, but we need a precise combination of that as well. So we can more data, and then we can build up some function to tell us what the best combination of simple and best is, and we put that, we get a new function. And we can keep playing this game as long as you want. You can keep throwing in things. The whole point of framing everything as an optimization means you can just put in more functions. All of this, of course, assumes we can find this best or simplest or best and simplest, and that there's actually one answer, the answer we're seeking for. So, what are the lens components? In summary, they're interrelated, right? There's a desire or need for precision that fuels the mathematical language the lens is based on. There's a belief in the power of data to reveal what is hidden. There's a belief that there is indeed a pattern to find, and that pattern captures some deep truth about human behavior that we cannot otherwise characterize. After all, if you found patterns and they were silly patterns, you wouldn't care about them. We believe that patterns mean something. And the belief also that this pattern that we're looking for manifests as some kind of best-in-class object, and that we can define what best is, and therefore can find what the pattern is. What are the limits of such a lens? I've argued that a lens simplifies. We can see all the ways in which the lens simplifies, how we are. But simplification by itself is not a problem, right? You don't want a map, like Borges wrote about in a short story, that's as big as the thing you're mapping. It's okay to simplify, as long as you're capturing what you believe are the important characteristics of the thing that you're mapping or simplifying. But there are limits. And so if we're going to use a lens that we use so regularly, it sort of behooves us to understand where the limits of that lens are. As the joke goes, not all cows are spherical, and not all humans are rational agents or even agents with bounded rationality. And indeed, the challenge of any modeling approach, if we want to use it sort of honestly, is to understand the limits and where it fails to speak to the human condition. And crucially, whether there's a way to fix this in the model or not. One of the books that I've been influenced by over the years is this monograph by Michael Sandel called, The Moral Limits of Markets, where he lays out an argument for why a market-driven lens cannot capture all of what our moral intuitions are attuned to, whether it be something as mundane as line standing, the idea that you pay someone to stand in line for you, or something as serious as organ donations. I've been inspired by this to sort of think about what the limits are of this algorithmic lens. What are the things it cannot do for us? Right? And what would those even look like? So I'm going to go through one by one all the different components of the lens and argue for what I think are the limits of the lens in that particular component. So let's talk about precision for a second here. Right? I've said that the algorithmic lens expects precision because it works in the language of mathematics. Is there anything fundamentally wrong with that? Well, the problem really is that the description of human activities is fundamentally imprecise. It is not amenable to the kind of mathematical language that we expected to be able to work with. And it's laden with ambiguity both by design and by circumstance. The algorithmic lens, needless to say, does not function well with ambiguity. It can handle some kinds of ambiguity, but only if you can make that ambiguity precise itself, maybe via probability distribution or some kind of Bayesian reasoning or whatever. Inputs must be precise. Is my race black or is it white? Am I Asian? What does it mean that my son is half Chinese, half Indian? What does that even mean? What is that? Is it actually half? Is it less than half? Is it more than half? How do I even say these things? How does a lens capture the fact that I might present differently here in Providence, wearing a jacket, which is a rare thing for me, whereas when I'm in Salt Lake City, when I definitely am not wearing jackets, or where I'm in DC, where I wear even more fancy clothing than here because I'm required to. How do you capture the fact that we change our context, that we change how we present ourselves in so many different settings, all the time, unconsciously and consciously, depending on who we're talking to? Precision essentializes. It etches characteristics on one's forehead in stone, never to be changed. Because in order to describe someone, you have to write them down. And you can't change that. And then this leads to things like this, where you have technology that tries to infer things about us that are much more fluid than the technology is capable of handling. And people keep putting patches. They put, okay, we'll fix this, we'll add more categories, we'll do this. But fundamentally, you're trying to address something that is fluid and ambiguous and ever shifting with something that isn't. And that's a limit of precision in this lens. But even if you ignore the way in which precise representations fix one's identity in a way that may not be comfortable to us, what happens when the ambiguity you're trying to resolve doesn't reflect, it reflects some basic disagreements on the interpretation of a concept? Returning to hiring, for example, this, in the algorithmic lens, you can't predict success and failure. That is not a well-defined concept. You can try to predict, we'll be in this same job after 12 months. That's a measurable thing, and you can try to predict it. But is that success? Well, it might be success if there's rapid turnover. And getting someone to stick around for 12 months is a major success. Okay, maybe that's a good thing. But it could be failure if people tend to get promoted quickly. So why is this person still in this job for 12 months? What have they done? What have they not done that they haven't moved up the chain? What counts as success and how we interpret it might vary, not based on uncertainties or ambiguities in the concept, but based on who's asking. And while it's possible to make precise copies of the model for every version of what someone might ask, that rarely, if ever, happens. What does happen is that one choice of encoding, one definition of success, one way of representing your identity gets embedded in the design in some invisible way at some point at 2 in the morning after lots of Mountain Dew. And it's left buried till we discover a problem later on. And this is often what we mean when we say that values are encoded in an algorithm. It's not that someone is actively trying to do this. It's that the way we have to translate dealing with human engagements in the language of data science forces us to make these choices. What is the idea that more data yields more truth? One of the more obvious problems that we've been hearing about now for a long time is that, well, what kind of data are you getting? As we know now, if you train a model on data that's skewed towards one demographic or another, the results of the model will be similarly skewed, either giving favorable answers for that group or better error rates for that group. The saying, garbage in, garbage out in computer science applies here as well. Garbage data in, garbage data out. Maybe you're building a risk assessment tool and you want to collect as much data as possible because more data is more truth. So you pick up an individual's prior criminal record. Maybe you look at the number of times they've been arrested. Now you've introduced a bias because the data you're collecting is a product of a deeply inequitable social societal sort of conditions. And more data merely means more biased data. On the one hand, the limits of data is probably the most well-understood source of problems with data-driven decision-making. At this point, I think anyone who claims they do not understand that data can cause biases is committing data malpractice. So that's good. On the other hand, and strangely enough, there is this strong conviction that if only we had more data, we'd be just fine. That this data is terrible, but let's just get some more. It doesn't change the underlying problem. And all it does is help build a growing surveillance apparatus around us in the hope of getting better data. And what about the idea that there is a hidden truth, that it captures the likelihood of my doing well in a job? As I've said, the quest to find that hidden truth flattens the description of people. It assumes that two people described by the same chosen data about them must in fact be the same. Because the way the algorithm works, if it sees two descriptors that are the same, it will give the same answer. So if we have decided that I've collected some amount of data to make us look the same, we are going to get similarly treated regardless of what the truth is about us. It's rather than embracing the variations that we represent on all of us, the system thinks of us merely as variations on a theme and tries to find the theme itself, subtracting out all the variations. It is a very inhuman thing to do. And this is not the only way in universality this idea of hidden truth fails us. It fails on the assumption that there is in fact some hidden truth to find. Right? So consider a screening process in which a video camera records your every move, intonation, and facial expression. this is not sci-fi, this is actually real, in the hope of inferring something about your personality, which in turn is used to infer something about your fitness for a job. Is there any reason to believe that if you connect enough information about your physiological markers, that something about you can also be inferred? This is not a claim that you can just assume to be true. It needs to be tested. It's often not tested. And in fact, if we're talking about emotions, where there's extensive research now coming to the conclusion that you can't actually do this, that what we even call emotions in this very interesting book is sort of our attempt to create a story, a narrative around physiological reactions that we're getting, but that the stories themselves and what we call emotions are contingent on where we are in space and time and in what context. That emotions aren't intrinsic, but are layered and contextual. That doesn't bode well for your video camera trying to do a layered contextual analysis of your face. Indeed, ML is often called modern phrenology. We're not maybe looking at bumps on your head anymore, but if we're looking at bumps in a signal produced by a camera looking at your face, maybe it's not that much better. And the idea of a hidden truth, and most of the papers I write start off as rants because I'm really annoyed about something, and that annoyance just because I'm an academic converts itself into a paper. And one of the papers that we're writing right now is starting with this annoyance that we take for granted the idea that there is some hidden truth to be found whenever you do any machine learning, that it's always there. This is, first of all, both the shakiest part of the edifice of decision making, because it's often not true, but it's also the hardest one to question, because it's deeply connected to the idea that data is truth, and there must be laws governing human behavior that we can discover, that there just have to be. It doesn't make sense that there aren't. That's what I've heard, basically. This is the argument. It doesn't make sense that there aren't, therefore there must be. Finally, we turn to optimizations. Right? One thing we already know, that if you define best and you do it carelessly, you say, oh, best means I match the greatest number of points, then often that rule is going to ignore a small number of points where it makes a mistake. So for example, if you're trying to figure out how to separate, what in this case are correctly blue versus red points, you have this line that separates them and you feel happy, except that for those squares, you got it wrong. But because your classifier is trying to maximize the number of points for which you can do this correctly, it's like, it's a small set, it's fine. I'm pretty good. I got a reasonably accurate answer. Problem is, small sets of inputs is the very definition of demographic minorities, which explains many of the problems that we see with automated decision-making and discrimination. There's a fix for that specific issue, at least some kind of fix, right? But it brings us to a bigger problem. And this is a theme I keep returning to, that, we keep trying to fix problems that we see with more problems without realizing that the problem is inherent in what we're doing. We assume that we can, in fact, define what best means, that we can find it. But even that is not true. In fact, most ways to define best that somehow resembles reality are computationally intractable for the most part, which means we have no real hope of finding the best answer or even getting too close to it. And if we don't get the right answer, we just come up with anything, fairly arbitrary, which can make no claim to being best. I often liken this to saying that, machine learning training is often like taking, a 50-dimensional roulette wheel, throwing a ball in, seeing which slot it ends at, and saying, that's my procedure for deciding your fate. It's a classic problem in computing. Right? All the interesting problems are hard to solve, and all the problems you can solve easily aren't that interesting in the first place. And this gets to a bigger, even more thorny issue, and one of power. Who gets to define best? Is it best for a company that people it hires stay in their jobs forever? Or that they're restless and leave after a few years for a new and better one? What's best for the hires themselves? Who gets to make that decision? Usually, it's the one who paid for the software. That's often not the people who are being affected by the decisions. So the limit of this optimization type approach is often that it ignores the underlying power structures that often just get amplified and reinforced by the way these systems are built. That wall now has a door in it, by the way. Because none of the above limits that I told you about are dead ends. They're not things that say you can never, ever use data science to do anything involving people. That's not my point. Because often all it takes is awareness of one of these limits to think through a better way to model a problem or collect better data or formulate a better claim for the underlying mechanism or just optimize better. But these are real limits, don't get me wrong. And for many problems, these limits are do not go further signs that indicate the algorithm lens might fundamentally prevent you from understanding what's happening. You should just abandon it altogether. This abolitionist idea in the use of tech. And there's some cases where you should just not use it at all. But there are also many, many opportunities that the algorithmic lens provides. And in these opportunities is a way to rethink how we use the lens in order to be more responsible, more insightful, and more effective at addressing these broad questions of social import. I should keep track of time. I'm not sure how much I'm doing on time. Okay. Let's go back to our lens components again. Precision forces us to be excruciatingly clear about assumptions and choices. While a careless use of precision sweeps important value choices under the carpet, a commitment to an awareness of precision actually reveals inconsistencies and ambiguities in our thinking that need to be exposed. If you've ever done any modeling, you know how this works, right? You have someone has come to you, they're trying to model a problem. You start asking questions, and you ask more questions, and you ask more questions, and you realize that the problem is no longer what you thought it was, which is how to model phenomenon X. The problem was that we don't fully understand phenomenon X. And that's where the real issue is. And so that process of trying to attain precision is actually infinitely valuable, even if you actually don't get as precise as you want to be. So the lens is like a bright light in this case, to mix some metaphors, that illuminates our assumptions and lack of clarity. Precision allows us to isolate specific mechanisms in a social process to see if they work. Because if you can isolate one mechanism that doesn't work, maybe you're not so sure about the whole system anymore. So as a way to check whether the system is working or has some problems, it's very helpful. For a while now, people have been trying to build systems that predict where crime will occur. The hope is that by predicting where crime will occur, patrols could be dispatched appropriately, stemming the tide of crime. The problem, of course, is that if you send police to where you think crime will happen, and they arrest people on suspicion of crimes, and this data gets fed back into the predictive model, what you get is some kind of feedback loop. So this is intuitive, right? You feel, okay, this seems about right. This kind of thing should happen. But then this is also an opportunity to test out a very precise modeling prediction. Can we model the process of a system predicting crime, sending patrols to the area and observing activity deemed criminal? And can we see exactly how this feedback loop will play out? And this turns out this is exactly what we did in a paper we wrote a few years ago. We built a model that simulated the effects of one of the existing predictive policing models and tested with slightly incorrect and biased initial guesses of crime rates, just off. And what we observed, and this is very important, is that even slight differences in initial beliefs, discrepancies, got compounded rapidly over time. And eventually all resources were shifted to the one area that appeared to have more crime initially. Appeared to have more crime. Because it turned out that even if you got correct feedback afterwards, it was too late. The system, in fact, did not learn. The initial biases and the compounding effect were enough to overwhelm any actual data coming in from the system. And there's a sort of very nice sort of little theorem that was proved many years ago about these things called Polya-Ernst that goes into this. But the point is that you can do this by coming up with a simple model. And of course, when we talked about this, everyone said, oh, so are you trying to build a new predictive policing system? It's like, no, that is absolutely not the point of what we're doing. We simplified the heck out of the system in order to isolate a component where we could show where the problem was going to occur. And in that sense, precision and the ability to diagnose faults is something that this lens can do extremely well and has done very well in auditing systems, and that we should treasure and sort of see how to exploit more. What about data? Well, we already know that invalid, biased, and inaccurate data makes our lenses go astray. And one of the horror stories that we've heard over the years about how Amazon built a hiring system and it discriminated against women. But the real story is, in fact, a little bit more complicated. It's true that the hiring system ended up being biased. And as far as we know, the system was not, in fact, deployed. It was discovered to be biased internally and then abandoned. But what's more interesting is the fact that how the system revealed biases. it really, because it was trained off of data from Amazon's prior hiring, revealed a pattern of bias in hiring that Amazon had been doing. The building of the model, the collection of the data, revealed biases that have been very hard to argue about in the absence of that. Because you're saying, oh, I'm just building a model, this so-called neutral model from prior data, and look what happens to it. Well, this is because your data had problems, because you were doing problematic things. So again, the algorithmic lens in this case, by telling us to collect data and build models of this kind, is revealing problems in the system. And this has been true, for example, in many of the sort of criminal justice realms as well. What about what we choose to optimize? Well, what we choose to optimize is like an incentive function. There's no real reason to choose the obvious optimizations that sort of are convenient for us. We could ask to optimize other objectives, even ones that upend the power dynamic between systems and their subjects. And this has been already is work that people are doing right now, saying, well, what if we optimize for welfare? What do we optimize for the welfare of the many? What if we try to understand power relationships and optimize to upend those power relationships? These are all things we can do because we can choose our functions appropriately. And in doing so, we expand the scope of what we can do with the lens, which is far beyond what people have done because they had no reason to ask. But now we can because we know we can. And in some recent work that we did, we explored this idea of precarity. So while automated decision systems are often evaluated in a one-shot setting, the effect on people are often persistent and compounded. We've seen this spiral particularly vividly right now during the pandemic. A daycare closes, it destabilizes one's ability to work, which in turn destabilizes one's ability to get healthcare, which makes one even more vulnerable to COVID-related ailments. Everything is connected, and there's these compounding effects of decisions. And most attempts to study the results of decision-making don't look at that compounding effect because they look at the aggregate effect of a one-shot decision over a population rather than looking at the compounded effect of a series of decisions on you. So here the question is, well, can we even measure this properly? And so the initial work that we've been trying to lay out is how do you even measure what it means to have a precarious existence, one where small shocks can have a ripple effect that lasts a long time. And once you measure it, can you then talk about trying to focus directly on this with your interventions, rather than focusing on broad population-level characterizations? Precision comes with the ability to articulate what is not possible. This is an idea that's taken for granted in the mathematical disciplines, but it's kind of miraculous in its own way, right? The idea that you can prove that something is not possible or intractable is important because it indicates the futility of a particular approach, as well as pointing out how to redirect one's efforts, saying, don't go here, but you could go there. It's kind of cool. And this is particularly useful, and it has been particularly useful, when seeing how to determine whether a particular way of defining fairness makes sense. One of the more important insights that's come out over the last few years, these are some of the papers that did this, said that there isn't a single solution to the problem of discrimination by algorithm. Because, again, if we want to define non-discrimination, if we want to be precise, we might say, well, the chance of receiving a favorable outcome shouldn't depend on your personal attributes unrelated to the job. By law, attributes like gender, race, age, religion, national origin, sexual orientation would fall into that category. Right? Your outcome should not be affected by any of those things. But another way of thinking about this is that the decision-making process should be accurate to the same degree. So not just that you get the outcome, but that there should be accuracy in the process, regardless of these personal outcomes. It should be the case that the system for predicting credit scores works better if you're young than if you're old, for example. Well, it turns out this quest for a universal definition, a single definition of fairness is not going to work, because we can prove that these different notions of fairness cannot be simultaneously satisfied. This is a purely mathematical statement. And the proof actually reveals what kind of assumptions you need to make about your data for these two notions to coincide. And needless to say, they're very rare assumptions. They're not likely to work in practice. And while this result has been somewhat misunderstood, it's been used as a rhetorical culture to say, well, we can't come up with a single definition, therefore we just give up and not worry about fairness at all. But what it's really saying is that, no, the decision point about how you think about fairness and justice is not located in the algorithm. It's located in the people making the decision about the algorithm. So you can't cop out and say, well, the algorithm did this. You are making decisions about what you believe to be non-discrimination, and the algorithm is merely encoding it. It's not going to save you. And I think that's very helpful at all. It's kind of a neat trick for a formal approach to say, by being formal, we can tell you that this can't be defined formally. So the idea of being machine readable itself, which is a title of a story by Cory Doctorow, sci-fi geek, is trying to capture what a machine sees when it sees us. And I've tried to argue that the way a machine sees is through this algorithmic lens. And the reason I believe it's important to recognize this lens is because it's already happening. Algorithms are already reshaping us in how we function in order to be seen by systems. Whether it's to run the gauntlet of automated hiring system, or the thousands of ways in which algorithms mediate our experience, the way in which I have to decide whether to like one particular track on Spotify versus not, because I know it's going to send me a whole bunch of crap if I hit the like on the wrong one. We are being trained by the algorithms. There's something wrong about that. And going back to the beginning of my talk, right now, when we were talking about the role of data science in a liberal arts curriculum, none of this can be done in one disciplinary home. Definitely not within a data science disciplinary home. Throughout this talk, both indirectly and directly, I've referenced a host of disciplines, mostly the social sciences, whose insights are very crucial to bring perspective to the power and limits of the algorithmic lens. I view this project of bringing data science into a broader liberal arts discussion as the project of understanding, unpacking, and sometimes routing around this algorithmic lens as needed. And it's a joint project between data sciences and the social sciences. In fact, this sort of stylized description of the spaces and those lines between them represent all the work that I've been doing over the past few years. It doesn't usually sit in one of these boxes. It has to go out and reach out and make connections with different groups of people. Because there is no other way to talk about this. This is, it's not even interdisciplinary. It's somewhat in the middle, not of one or the other, which is both fascinating and also terrifying at the same time. I constantly feel stupid all the time, which you get used to after a while, but it's the right thing to do. You have to do it this way. I will leave you with a proposition, but with no proof, hopefully with a justification. Recognizing that the algorithmic lens exists is the first step towards realizing that merely replacing one piece of tech with another is not going to address the many challenges that technology has placed in our path. And getting rid of all tech is not going to work either. I think that ship has sailed. We have to learn to live with this new lens. We have to understand its power and its limits. And we have to figure out how to integrate it into the very human world we live in before we end up being molded into a form that fits a machine-readable world. And with that, I thank you for your attention. I acknowledge the many, many collaborators that I've had over the years. These categories move. People who used to be collaborators became special guests and might be introduced into the band at some point. And I thank you for your time. Questions? Comments? And there's a microphone here, I think, for people in the room we can use. I believe there may or may not be questions from the live streams. Yes?
Hello, thank you.
If it's not too much trouble to use the microphone, I think it's mostly for the live stream folks so they can hear. Yeah. And hi.
Hey, Suresh.
Good to see you again.
Good to see you.
Yeah.
So I had a question about your precision lens.
Yes.
So you said precision is what it masks, sometimes masks, is ambiguity.
Yes.
And I was wondering about another sphere where we trying to make somewhat precise judgments, but that can also sometimes mask ambiguity, and that's the legal sphere.
Yes.
So legal judgments, we often think of laws as being very precise, as laying out very precisely the criteria for how we should judge a particular case. So so we're already doing this in a way. So what you're saying we're doing in the algorithmic world, we're already doing that in the physical world, in the legal world. But what legal scholars in a way recognize is that we shouldn't, there should be two things. So there should be, on the one hand, there should be accountability. So we recognize that we are masking some ambiguity, and therefore we have a somewhat iterative process of going over laws, of making sure that they still fit, that they still don't brush over too many ambiguities. Another aspect is the recognition of, that's something that legal philosophers often talk about, the idea that if we are applying this lens, this kind of precision lens, to too many spheres, it actually constrains. So legalization of society, legalizing all moral wrongs would be a bad idea because it constrains. So I was just wondering if any of these ways of framing precision and our reaction to of this idea of making things precise in the physical world might also reflect on the algorithmic sphere in a way. So I was just wondering if you see any connections there.
Oh yes, I think I've spent more time than I should have trying to figure out how this, for example, there's this notion of vagueness, right? The formal notion of vagueness in the law, that vagueness as a good thing, that you want to allow for constructive ambiguity in specification so it can flex to the context as needed while articulating some broad principles. And then the question of how far you go in that direction is exactly the kind of tension you've been talking about between rulemaking and arbitration, right? Do you set up rules ahead of time that everyone has to follow? Do you set up guidelines and let the courts figure it out? The courts being a way to navigate vagueness in the context of a particular case. And this tension constantly goes back and forth depending on what the context is. So I think this is very much in line with how I'm thinking about this. The algorithmic lens, as far as I think about it, and maybe others can tell me why I'm wrong here, please tell me I'm wrong here, that it does not have a way to navigate smoothly this place between precision and a constructive vagueness. The law does. It seems valuable to do it, especially because we're dealing with fundamentally imprecise notions and contextual notions. If we could do that, then we might be able to make these notions. And in fact, the reason I think, and student Lizzie and I, we've talked about this and thought about it for a long time. The reason why we have collisions between the law and ongoing technology is at some level because of problems like this, that what are irreducible ambiguities do not mesh well with these irreducible precision statements that we want to make in machine learning. So very, very valid point, yeah. Yes, please.
Thank you very much for this talk. I was just wondering, it struck me that a lot of what you're talking about in terms of the algorithmic lens could be attributed to a certain type of politics, in the sense, in the sense that if you have a lens which illuminates some facts at the expense of others, that could also be called a political viewpoint.
Yes.
In the same way, if you're optimizing for a particular thing, you are choosing to privilege some persons at the expense of others, or some factors at the expense of others. What is the usefulness or not of talking about computing as fundamentally and intractably political? Is it useful to talk about it as political, or is there a reason why we're avoiding this term?
Well, this artifact definitely has politics. I would say, if Provost Locke were here, I would ask him to answer the question, because I'm not a political scientist myself. I think my narrow vision is because, as a computer scientist, I'm interested in the objects I study and what components they carry along with them. I definitely think that there's a political angle to this, but I don't think the political angle negates or replaces the components I'm talking about. I think it complements them. And that provides a whole other dimension, because as you pointed out, we make choices about how we decide to design systems a certain way, and that is a political choice of a kind. But I think it's not, I'm not sure I can fully answer this, because to me it feels like the reason we design systems the way we do, computer systems, is to some extent still a function of the thing itself. It is not purely coming from a political agenda. It has components to it that are just innately quantified and built up in a way because that's how we've always built them. I don't have a better answer to that than that. So I would love to hear more and understand more about the political angle, while still retaining my belief that these perspectives are in fact relevant. These more technical perspectives are still relevant to it. Yeah.
Hi, thank you so much for this talk. It's really interesting. I'm curious how you think about incorporating the algorithmic lens and the awareness of it into education, particularly at the undergraduate level. You know, we have this program at Brown called the SRC, and
Yep.
we definitely have not discussed a lot, at least in the classes I've taken with SRC, the underlying assumptions about how we actually go about solving problems. So yeah, I'm curious what are your thoughts about that.
I mean, this is something that, you could answer this question as well, Julia. So I know that folks at the CS program are thinking very actively about all of these questions. So I think you're in good hands there. But I think from my perspective, coming from Utah, where we taught some of these things, I think some of the challenges are really that you have to have some facility with the underlying tools before you can start critiquing them. So there's a sort of a graded process of introducing more complexity into one's thinking about these topics. So it's not something you'd enter in on day one of your class, but you'd want to be able to make sure when you left your program, when you left your degree program, you do have this deeper understanding, sort of a critical understanding of the field, right? So we talk about critical theory, we talk about a critical view, and we talk about the humanities, we talk about reading a piece of literature. I think a critical view of how we design a piece of code in this sense is a valuable one, and there's a time and place for it in the CS curriculum, I believe.
Thank you for the talk, and I apologize for bastardizing one of your points in advance. But I believe you said something like there's an underlying assumption that there is some underlying truth through the algorithmic lens. And I'd like to ask, do you think that's really an assumption of the algorithmic lens or an assumption of the inferential lens, or the idea that anything at all can be inferred?
Yeah, so my wording is clumsy. I think you're correct. It is the assumption of the inferential lens, that we're trying to infer something, so therefore something must be there to infer. I agree.
So you gave resumes, an automated resume reading as an example, but to me it seems like we're not really making that strong of an assumption beyond, if a human can read a resume and determine whether to hire someone, then there is some underlying truth.
Is there?
Is that fair? Well, if the human, I would say...
Which human? I might read it differently from you.
If any human can do it, then there is some truth that is visible to that.
But just because any human can do it doesn't mean any human will come to the same conclusion about it. That's the problem I'm facing, right? That we all bring our own, we say that we want to build these systems to remove our biases, but maybe once you remove the biases, there's nothing left. That these different perspectives are all that we have. I don't know the answer. My biggest beef is that no one even bothers to ask the questions. That's my biggest concern.
Thank you.
Yes. Sure.
What?
You can go ahead, ask your question, and we'll figure it out for that. Yeah.
So
Sorry.
I guess I have a question that what is the definition of fairness? For example, because in artificial intelligence, we say there's this Turing test that something can think like a human, like a machine thinks like a human if we pass this test or no. But what is the definition of fairness? Because humans are not fair either. So what is this thing that we are looking for?
I don't think there's a definition of fairness. I think that you can define various forms of unfairness, and you should. And the absence of unfairness is not the presence of fairness. But I think that the obsession with defining fairness has been a mistake.
I guess my question is when we are saying that I want to make a decision, but there is no underlying truth in my data, then what are we seeking for? Like that's like not really well defined in this. thing for me.
I think we are seeking many things, right? So, if you look at narrowly the language of non-discrimination, what we're really saying is we acknowledge that historical inequities have made, people who should otherwise have the same opportunities and present the same way look disadvantaged. And we want to make sure that in some ways that are reasonable, we can correct for some of these disadvantages, right? Broadly speaking, the idea of the Civil Rights Act, the idea of sort of, having non-discrimination clauses basically says you should not be treating people differently based on these characteristics. That's a very specific form of unfairness that you're trying to avoid. Does it capture all notions of unfairness? No, it does not. And that's why I was careful to say there is no definition of fairness. All happy families look the same. Every family is unhappy in its own way. It's the same kind of thing, right?
Yeah.
The different notions of unfairness in context look different. And you have to look at that specific context and understand what is it you're worried about there. Don't try to come up with a single universal definition.
Yeah, thank you.
We can pass the mic. Maybe, someone in the back. You can just grab it and give it to the next person.
Hi. So I suppose my question for you is sort of like, you've covered a lot of different subjects and a lot of sort of different components to, all the challenges and, fairness, bias, et cetera. But I think my question for you is, where do you see like this literature? Where do you see, this field sort of converging? Where do you see people and research sort of? Where do you see that heading toward?
I hope it doesn't converge, actually, to be honest. I think convergence would be a bad idea. We'd all start agreeing on everything. I think, so I haven't been working in this space very long, right? People have been doing this for decades. But even within the CS sort of community that's been thinking about this, I've seen already 3 or 4 generations of thinking happen just in the last few years. The initial pursuit to define specific definitions of fairness, the realization that this doesn't capture all of the things we are concerned about, the idea that we can expand the scope of how we think about what we want to optimize for. All that I've been seeing happening. And I don't know, it's just very exciting to be along for the ride. I can tell you what I would like to see. I would like to see us begin to move away from trying to fix all the technical problems and start using, the algorithmic lens to help diagnose more problems. I would like to see us think of different ways to use our tech to be more harmonious with how we want to live rather than telling us how we want to live. I'm not saying we're not doing those things, but I'd like to see more of that. So that's my personal bias, but we'll see what happens.
Thank you.
Behind you.
My question is, a lot of the ideas about fairness are fundamentally issues about social justice. So when you're tackling an issue that's so interdisciplinary, what is the role of like a liberal arts education, people who come from those different backgrounds in constructing those algorithms? Is it during the construction process, in the process about refining them, or even determining what type of challenges need to be solved?
I think it's everywhere. I think that the groups that have been successful in thinking through these issues are groups of interdisciplinary teams that start together and work together, and don't necessarily say, well, you do this piece and I'll do that piece, right? So I'm working with a colleague now who's a sociologist, and we wrote up some formal description of an algorithm, and she looked and says, okay, I don't understand algorithms, so can you explain how this works? Like, oh, we can't explain it because it doesn't make any sense to us either now that we think about it. So so this idea that people have their domains and they bring that domain is yes, but I think what really happens when I have found sort of the learning light to go off in my head is when we're actually just talking. We bring different perspectives, but the problem is something we're all talking about at the same time. We're not just carving out our different pieces and I'll work on this piece and you work on that piece. So the role of the liberal arts education, the role of this broad education is to be able to bridge those gaps, to be able to communicate, to understand when someone comes and says, race is a social construct, not say, I don't want to hear that. It's to say, okay, I understand what you're saying, right? Because I am never, ever going to be anything more than just an eager student in all the fields that I interact with others in. But if I can understand what they're telling me and I can communicate something back, then we have a discussion going. Because that's the biggest problem, being able to talk with each other, understand our perspectives, understand what we all care about, and then trying to find ways in which we can all sort of move together. So you don't have to know stuff. You have to be able to understand, and you have to be able to communicate. And I think a liberal arts education does a lot of that.